with the help of this asymptotic notation, we will be able to understand the complexity of any of an algorithm. When we are representing its time and space complexity in the terms of mathematical representation, then we are going to call that as a asymptotic notation. X-axis will going to show you the number of input that we are taking, and y-axis specifies the maximum time what it will going to take. How we are going to define this big theta notation? It will be in the terms of theta of g of n. Hello everybody, a warm welcome to one and all. Welcome back to the session 4 of chapter 1, and we are in the unit 1 of B.C.A. second semester, subject called data structures using C. I am Rohini TS, Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So in our today's session, we're going to have a look regarding this recursion. Before getting into that, we'll just have a quick recap of my previous session. So as we all know that in the previous session of this chapter, we had discussed regarding algorithm, right? So what do you mean by an algorithm? What is its advantage? What are the characteristics of algorithm we have? Along with that, I have discussed regarding algorithm specification, how algorithm will going to be specified. It should be finite in number of steps, and input it has to take, output it has to display, effective, all those stages or specification of algorithm that I have discussed in my previous session. And also we got to know regarding performance analysis. So analysis of any of a performance of any of an algorithm will going to be done in two terms, like it will be based on the time complexity as well as the space complexity. That is what I have discussed in my previous session. So in our today's session, we'll see about the performance measurement of an algorithm. So now we got to know what is an algorithm, what are the specification we have in algorithm, and also I have discussed regarding how performance analysis will going to be measured. So now we'll see how this performance measurement will going to take place. Along with that, we'll see about a new concept called recursion. So we'll see the definition of recursion, and also we'll see how it will going to works, along with what are the types of recursion we have. And then let me discuss about this advantages of recursion. As we all know that if you have advantages, there must be one or more disadvantages also. That is also I will be discussing in my today's session. Let me get into the today's topic, that is regarding performance measurement. So before understanding what is performance measurement, what are the notations or what are the symbols we are going to have it in order to measure the performance of an algorithm. As we all know that what is algorithm first? It is a step-by-step procedure to solve a given problem, right? Then how can I choose this algorithm is best to solve my problem? We are going to have several number of algorithms, or we are going to have a different ways of writing an algorithm for a same problem. As we all know that in the computer science, we have a many ways to solve a same problem. Out of that, we have to choose which is the best one to yield the result. That is what we have to analyze, or we have to get to know which is the best among the given option. Then when we are using or when we are choosing that analyzed algorithm, that has to give the result within a given time, and it has to take less memory space. That is the main agenda of this performance measurement. So the measurement will going to be in the terms of time it will going to take, along with a space or a memory that it will going to require. So that performance measurement measures the space and time taken in the actual runs. So if I am using any of the algorithm to solve my problem, at the time when we are giving all the kinds of input to that particular problem, at the time, then how much time it will require, what is the memory space it is taking when it is running. Based on that, we are going to measure this performance measurement. So in this performance measurement, when we have to perform or when we wanted to analyze that algorithm, then we have to calculate the complexity of an algorithm. That includes space complexity as well as the time complexity. But when we are finding that space complexity and time complexity, at the time we won't get to know the actual or accurate resources what we require. We won't get to know about the exact number of resources that we require in order to solve a given problem by making use of any of an algorithm that we have chosen here. So that in order to measure this complexity, or in order to represent the time and space what it will going to takes place in the solution or in finding a solution of any of a problem, at that time we are going to use one mathematical symbol or mathematical notation we are going to use. Then that will be considered as what? Notation, or that will be considered as asymptotic notation. So with the help of this asymptotic notation, we will be able to understand the complexity of any of an algorithm. It will going to give you the maximum time required, minimum time required, and what must be the average time that it will require in order to understand or in order to measure the performance of any of the algorithm. So now you can see here we have a asymptotic notation. So in this asymptotic notation of an algorithm is a mathematical representation of its complexity. So when we are representing its time and space complexity in the terms of mathematical representation, then we are going to call that as a asymptotic notation, and it will be of three types. One is big O and big omega, and we have a big theta here. So big O will going to be represent like this, and we have a big omega, and also we have a big theta. So all these notations will going to be used in order to represent the complexity of any of an algorithm in terms of mathematical representation. We'll see about the first type, that is regarding big O, right? So what I wanted to take first, for example, I wanted to solve certain problem, or I wanted to solve a particular problem. Then how it will be solved? First I have to give an input, then it needs to be processed. When it is processing, it will require time and memory space. Once it is processed, then output has to be given, or output has to be displayed to the user, right? This is what the scenario, or this is what the flow of an algorithm will be as that follows, right? So when we are using this big O notation, at that time it will just going to find, or it defines the upper bound of an algorithm in the terms of time complexity. This big O notation will going to give us, or it will going to define the upper bound. What is the maximum time it require? For example, I have one algorithm. You just imagine I have 5 algorithm here. Consider A, B, C, D and E. Okay, I have 5 algorithm A, B, C, D, E. Among that, I have to choose one of the best algorithm to solve my problem. At the time, I have to find out if I take this A as my solution for my problem, at the time how much time it will going to take for all the input. For example, if I have 100 number of input, for 100 number of input, how much time it will going to take in order to solve that problem. So, which is the maximum time it is taking? It will going to give you the maximum time or upper bound of an algorithm in the terms of time complexity. Among all these, which is taking maximum size or maximum time. So that big O notation always indicates the maximum time required by an algorithm for all the input values. If I have 10 inputs, what will be the maximum time? If I have 100 inputs, what will be the maximum time it will going to take in order to process or in order to give the solution for a particular problem? So always this big O notation specifies the upper bound of an algorithm, or it will specifies the maximum time what it will going to be required. And also big O notation describes the worst case. So if we have a maximum time, that means it will going to take 10 seconds. So that 10 seconds, if another algorithm is taking 2 seconds only in order to solve the same problem, then 10 seconds will be the worst case. So here you have to remember, we have a best case, worst case, and also we have a average case. In order to find the worst case, that means in the terms of maximum time it is taking in order to solve a same problem. So it will going to represent the worst case of an algorithm time complexity. And also we can see that big O notation will going to be defined in the terms of f of n as O or big O of g of n. So here in the diagrammatic representation you can see here, x-axis will going to show you the number of input that we are taking, and y-axis specifies the maximum time what it will going to take. And also we have a function f of n and c of gn. This is how this big O notation will going to be used in order to find the upper bound. So in the big O notation, we got to know that which is the worst case of an algorithm with respect to the time complexity. So now we'll see how can I get, or which will going to describe the best case of an algorithm. That is what you can see here in the big omega notation. So we are going to use a symbol to specify the big omega notation, so that in the big omega notation always it is used to define the lower bound of an algorithm, that is the minimum time it will going to take a given problem in the terms of algorithm of time complexity. Always it will gives you the lower bound, and always it indicates the minimum time which is required by an algorithm for all the input values. So if I have 100 input or 10 input, 98 input, how much could be the number of input? But what is the minimum time it is taking to give a resultant? That will going to be defined and designed by this big omega notation. And also it always indicates the best case of an algorithm. So big O indicates the worst case of an algorithm, big omega indicates the best case of an algorithm. Next we have a big theta that indicates the average case of an algorithm. So as of now, this big omega will going to describes the big or best case of an algorithm in the terms of time complexity. And how we are going to define this big omega notation? That will be in the terms of big omega of g of n. So that here you can see that f of n is a time complexity and g of n is the most significant term, that you can see in the representation of this big omega notation. Always this x-axis specifies the number of input it is taking, and y-axis specifies the time it will going to take, and here f of n specifies the time complexity and g of n is the always this most significant term. This is regarding big omega notation. So now we'll see about this big theta notation. So now we got to know that which will going to give you the worst case as well as the best case. Then which will going to give you the average case. That is with the help of this big theta notation we can understand that. So that big theta notation is used to define the average bound of an algorithm in the terms of time complexity. This big theta is used to define the average case it will require in order to solve any of a problem of an algorithm, that too in the terms of time complexity. And also it always indicates the average time which is required by an algorithm for all the input values. For example, if I have 10 input values, then how much will be the time it will going to take in order to find the average case. So if we get to know worst case, best case as well as the average case, then I can use the same thing for all the kinds of algorithm that we are using. Among that, we have to choose which is the best by measuring all the performance of an algorithm. So that big theta notation describes the average case of an algorithm time complexity. And how we are going to define this big theta notation? It will be in the terms of theta of g of n. So here you can see that x-axis will going to gives you the input values for n number of values, and also here we have a y-axis. This will going to give you the time, and also this f of n always give you the time complexity in all the kinds of notations. Here you can see that g of 1 is always below this average time, and g of n, that is the maximum number of input, will be always above the average bound. This is regarding big theta notation. So by making use of big omega, big O as well as the big theta notation, we can find or we can measure the performance of an algorithm. So now let me move to the next topic. So then, as we all know that already we know the terminology called function. Is this regarding marriage function? No, right? So we are talking about a computer function. Always we are talking about a function in the programming aspect here. So that when it comes to the function, it is a collection of instruction, or it will be a set of instruction which has been written to perform a particular task. Then we are going to call that as a function, right? So here we are going to have two kinds of function. One is calling function and another one is called function. So two terminology you need to remember. One is calling function and another one is called function. So in the calling function, what will going to happen? As I told earlier, we wanted to perform a particular task. In order to do that, we will be having this function, right? So in the calling function, I am just going to take the parameter, whatever require and what are the input that I require, everything that I am going to mention in the calling function, that will going to reach to the called function. So at the time, control will be going from calling function to called function. So when all the input and all the parameters or all the arguments which comes to the called function, in the called function, it will going to do the processing. So once it is processed, it has to yield the result. That resultant will going to be generated in the called function. Again, this called function will going to send the resultant back to the calling function. So this is how this called function, calling function will going to work. So mainly we have a function to perform a particular task. So in that calling function, called function. So I will be talking about the recursion. So in the recursion, calling function as well as the called function, both will be same. So that we won't have a override of calling, or by making use of this calling function, called function will not be there in the recursion. Both the calling function and called function will be considered as a same thing even in the recursion of a C programming. And also how this recursion function will going to work then. So recursion, as the name indicates, is like a looping. Okay, so it will going to display or it will going to execute a same set of statement again and again. It will going to call a function by itself. That is what calling function, called function, both will going to be merged together. Then only we can call that as a recursion function, right? So a certain condition will be there. So based on that condition, if it is true, then again it will going to call the same function, and if we have certain number of statement that will going to be displayed, again it will reach to the condition again. If the condition is again true, it will just going to be looped again and again. But you have to remember one thing, it can't be like continuous loop. At one and another way it has to stop. For that reason, we have to take one more condition, that is false. When the condition become false, at the time it will come out of a loop, and further whatever the statement we have, that will going to be displayed, and at last we have a stop. This is how recursion function will going to work. So you got to know, right? So function, we have a calling function and called function, both will going to be merged together. That will be considered as a recursion, and it will be like a loop. It will calling a function by itself. Then that process is called recursion, and this is what flow chart of this recursion. We have a condition. If a condition is true, again a same function will be called along with set of statement will going to be displayed, or it will going to be executed. Once the condition becomes false, it will come out of the loop. Otherwise, it will going to be looped infinitely. But we should not let the recursion function to be in the infinite loop. By giving certain condition, it has to be false, then it can come out of the recursion loop. So now you can see the definition of a recursion here. When a function calls a copy of itself, then the process is called as recursion. As I told, when a function is calling itself, if you are calling your name, then that is what? Recursion. When a function call a copy of the same function, then we are going to call that as a recursion. And the function is known as recursive function. So the method what we are performing, calling a same function again and again, is called recursion, and that kind of function will be considered as recursive function. And in this recursion, calling and called function both are same. We won't differentiate calling function and called function. No need to send argument from here to here, and here it will not going to process again. It won't send the resultant back to the calling function. That kind of things will not take place in the recursion. And this recursion will going to have two parts always. One is what? Smallest part, and another one is general method. So in the smallest part, always base case that processed without recursion. It's a certain statement will going to be executed, or it will going to take place without any recursion. But when it comes to the general method, so that reduces a particular case to one or more of the smaller cases. Mainly recursion will going to work based on the divide and conquer method. It will not going to consider a problem as a single unit. Instead of that, the problem will going to be divided into number of sub problem or a number of sub function. Then only it will going to be considered as a recursion, right? Function will be divided into number of sub-functions. Same thing we are having here, so that making a progress towards eventually reducing the problem in the way to the base case. So, in order to minimize the overhead of a base case, the function will going to be divided into number of sub-function. That is regarding recursion. And what are the types of recursion we have in a C programming? And moreover, it has a different kinds of recursion we have. So, among that you need to concentrate regarding direct as well as indirect as per your NAP syllabus. So, here what are the types of recursion we have? We have direct recursion, indirect recursion, tail recursion, no tail. If it is no tail, obviously it will be of head recursion, then linear recursion, and at last we have a tree recursion. You need to concentrate regarding direct recursion as well as indirect recursion, and you need to understand the definition of all these things in the terms of your examination point of view, right? So now we'll see what direct recursion is all about. So what is the definition of this direct recursion? When a function calls itself within the same function repeatedly. So already I shown you the how calling and call function will going to work. But here everything or calling and call function both are merged together, right? So when a function call itself within a same function. So we know that we have a return type, right? So return type will be there. And we need to specify the function name. Once you specify a function name, you need to specify the arguments that you have. So if no arguments, no need to specify. It will be a block of code which is going to yield a solution for a particular problem. This is what the syntax of a function usually, right? So when we are having this function, so for example here I need to give a name for a function. So when this function calling the same function within a same block of statement, then we are going to call that as a direct recursion. So when a function calls itself within a same function repeatedly, then we are going to call that as a direct recursion. What I am supposed to do, if I wanted to commit out of the loop, then the condition has to be false, then only it will come out of the loop. So that you can see the structure here, or you can see the example of this direct recursion. Here fun is a function name and flower braces will get open. That means scope of this function get activated, and we are going to write some code statement will be written here. And again I have one more function called fun. That means I am calling a same function within a same function, then we are going to call that as a direct recursion. At last I am going to close the scope of a function. This is how we are going to call a function name, and if we have any arguments along with a semicolon if we have mentioned, that is considered as what? Calling a function. So when function is called in a same function repeatedly, then we are going to call that as a direct function. So now we'll see about the second type of recursion, that is regarding indirect recursion. What was the thing which we learned in the direct function? For example, I have a function called A, then I wanted to call a function A repeatedly, then I don't require any other function to be invoked or to require in order to invoke another function. That is what direct function. So here you consider I have A, B, C as a function. I wanted to reach to C, or I wanted to call C. At the time A will going to call B, again B will going to call C. This C will going to communicate with A. This is what in a circular motion this will going to takes place when a function is mutually called by another function in a circular manner. So here A will call B, B will call C, again C will going to call A. That means mutually calling another function in a circular formation. That means the function is called as indirect recursion function. So you can see here in this general structure of this indirect function, we have a three function 1, function 2 and function 3. So in the function 1, function 2 will going to be called. Function 2 is calling here. In the function 2, function 3 is calling, and in the function 3, function 1 is calling. That means in the circular formation, function 1 is calling function 2, again that function 2 is calling function 3, and function 3 is calling function 1. It will be of circular motion. So we are going to call this kind of recursion as indirect recursion, and you need to take care about the definition of all other type of recursion what I have mentioned in the previous slide. I hope you all understood regarding types of recursion. So now you can see the advantages of recursion. So already we know what is function and what is recursion function we know. If I compare both of them, what are the advantages that I can expect out of this recursion? We'll see here, it makes the program elegant. It will be of easy, simple. It looks elegant with the help of this recursion function, and mainly it will going to gives a clarity to the program code and also reduces the time to write the code. So why? Because we are having a reuse in the recursion. No need to write a same code or a same function again and again from the scratch. So it will going to save the time and reduces the time complexity. Already we know in order to measure a performance of an algorithm, this time complexity will going to be needs to be very low. So when we have a less time complexity, then the resultant or its response time will be high. So that it also reduces the time complexity and also best use, or it can be best suited for solving the problems which is based on the tree structure. It will be of hierarchical form and problem will going to be divided into number of sub problem. In order to solve that kind of problem, this recursion will be very easy. And also this recursion is one of the application of a stack data structure that you will be learning in the coming session. So after knowing the advantages, so now we'll see what are the disadvantages we have in a recursion. Mainly, it is lower than the non-recursive function due to the overhead of maintaining the stack. So here, both calling function and call function both are merged together so that it will be of slower in execution, and also it requires more memory for the stack. Both calling function and call function, those two overhead will going to be takes place in a stack. So it requires more memory space and also it will be slower. So it has to call a same function again and again. It has to give a resultant. So that somehow it will be considered as what? Slower in the terms of execution. These are the disadvantages you can expect from the recursion. So after looking into these disadvantages, now we'll see what are the technique examples that we have with respect to recursion. So here I have listed out the recursion technique example that you can see here. First we have a GCD, that is greatest common divisor. In order to find the GCD of any given two numbers, then also possibility of having this recursion concept to find out that. And also we have a binomial coefficient and we have a NCR. This is regarding combination and permutation, so that there we are going to learn about the combination, and also we have a traverse of Hanai. It will be of very fun. You can understand all these technique example in my coming session. I hope you all understood my today's session. In my coming session, we're going to have all the technique example, that is recursion technique examples, and along with that, at last we'll see what is the comparison or a difference between the iterative and recursive function. That will be the content of my next session. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.